Hello everyone, I am Abhinav and today we'll be discussing the 13th problem from the CP-31 sheet by TLE Eliminators under the 1500 rated problems. Let's begin. We'll move on to our CP-31 sheet and we can see that the 1500 rating mark has been checked. Let's click on the 13th problem, which is Mortal Kombat. Okay, so let's read the problem statement. You and your friend are playing the game Mortal Kombat 11. You are trying to pass a challenge tower. There are n bosses in this tower, numbered from 1 to n. The type of the Ayat boss is AI. If Ayat boss is easy, its type is AI equal to 0. Otherwise, it's hard and its type is AI equal to 1. So there are basically n bosses and every boss is either an easy boss or a hard boss, which we can know from the array A. During one session, either you or your friend can kill one or two bosses. Neither you nor your friend can skip the session. So minimum number of bosses killed during a session is at least one. So in every session, if the session is by you, then you would kill either exactly one boss or two boss. You cannot skip it. Okay. After your friend session, your session begins, then again your friend session begins. So alternatively, first you would kill one or two boss, then your friend would kill one or two boss, likewise. The first session is your friend session, so it would start with your friend. Your friend needs to get good because he can't actually kill hard bosses. To kill them, he uses skip points. One skip point can be used to kill one hard boss. So if your friend is killing a hard boss, he would use skip points. Okay, one skip point for one hard boss. Your task is to find the minimum number of skip points your friend needs to use, so you and your friend kill all the n bosses in the given order. So basically you just need to minimize the number of skip points used so that you can kill all the n bosses in order. For example, like for n equal to 8, these are the order of the bosses. So the first boss is a hard boss, then an easy boss, then two hard bosses, likewise. Okay. Now you want to kill the bosses in this order only. So what's the best course of action in this? Your friend kills the first two bosses. So your friend kills these two bosses. So first one was a hard boss. So one skip point would be used. This was a easy boss. So no skip points. So one skip point. You kill the third and fourth. Then you would kill these two bosses. And when you kill a boss, no skip points are used. Your friend kills the fifth boss. Okay, so this was an easy boss. It is killed by your friend. Then you kill the sixth and seventh. These two bosses are killed by you. Then your friend kills the last boss, which would use a skip point because this is a hard boss. So in total, we used a skip point here and one skip point here. So two skip points were used. This is the minimum strategy for this particular order of bosses. Now, you are given t independent test cases and you want to find the answer for every test case. You can see the constraints on n is 2 into 10 to the power 5. Okay. So, I hope like in the first example, you would have understood. Still, let's take one more example to understand more clearly what you need to do. So basically you are given two things, n and an array of size n. Okay, this is what you are given as input. This basically means there are 5 bosses in this order. First one is a hard boss. This is also a hard boss. This is also a hard, and this is an easy boss. Okay, now your friend would start first. So you may have different strategies to kill. Let's suppose first your friend kills only one boss. Okay, so this is a hard boss, so plus 1 to the number of skip points. Okay, this is killed by a friend. Then you take the turn and let's say you kill two of the bosses. Okay, so no skip points for that. Then let's say your friend kills this boss. Okay, so plus 1 to the skip points. Okay, and then maybe you come and kill this boss. Okay, so in total two skip points were used in this strategy. Maybe we can have some other strategy also. Let's say your friend starts and he kills two bosses. Okay, so that would use two skip points. Then you go on and kill the next two bosses. That won't use any skip points. Then your friend goes on and kills this boss. So no skip points. This way also you used two skip points. Okay. There would be other strategies where you may use more than two skip points. Let's say your friend kills these two bosses and then you kill only one boss, then your friend kills these two bosses, so another plus 1 skip point would be used. So that would make a total of 3 skip points. So the best strategy here was with 2 skip points. So 2 was your answer for this test case. I hope 2 is the answer for this test case. Okay, so this is what you need to determine. I hope the problem statement would be clear to you. Now, how do you determine this thing in the given constraints of the problem? What is the constraints? N is up till 2 into 10 to the power 5, and the sum of n over all test cases is also 2 into 10 to the power 5. So basically we are given n less than 2 into 10 to the power 5. So with by looking at the constraints on n, what we can say, if we are using some code which has a time complexity of, let's say, order of n square, then that would have 4 into 10 to the power 10. This would definitely give us a TLE. This won't pass. But anything less than order of n square, something like order of even n root n or n log n, or something like order of n or lesser, these time complexities would be well accepted. Okay, so these you can say are our required time complexity. Okay, we need to solve the problem in one of these time complexities. By looking at the constraints, we can know that. Now we would try to solve it in some order of n, and if needed, some log n extra and all can be added. So let's try to think of some strategy to solve it like that. Now if you just think of the brute strategy, what brute approach of to solve the problem, what would it would be? Just try out all the combinations. How would you try out all the combinations? So initially your friend starts. Okay, so when you start the game, your friend starts from here. Now he has two options: either kill just one boss or kill two bosses. Okay, and then if he is killing one boss, then you would start from here. Okay, then you have the choice to either kill one boss or two boss. Or if in the first case your friend is killing two of the bosses, then you would start from here, and then you have the choice to kill either one boss or two boss. Okay, so you may recursively go on and try out all the types of combination, but that recursion, every time you have two choices, that like it would recursively go on and become 2 to the power n type of complexity if you just apply recursion. But just by looking at this, if you think, then it is somewhat of a DP problem which can be solved in order of n. How? Like just by looking at the type of the problem, like in every at every part we have some two choices, either kill one or kill two. So like we have different choices, and every time if you analyze the states, then we would start. So initially we would start from the first index with your friend starting first, and then if he kills two bosses, then you start with this index, third index, with you starting first. Or if he kills one boss, then start with second index, you starting first. So basically what state can we take? Okay, in general, whenever you want to apply DP in an array, the first most basic state to take is something like, okay, whenever you have a array like this, you have an array of size n. Okay, let's say I'm taking zero based indexing. Then the most basic way to divide it into a DP problem, take the states, is the first thing that should come to your mind is take something like a DPI, where DPI is represents your answer either for the prefix till I or for the suffix from I. Okay, so that's the most basic way to partition the problem. Whatever you need to find, what you need to find is minimum number of that skip points to kill all the bosses. That is what you need to find. So take the state as DPI is, let's suppose, minimum number of, okay, whatever you need to find, minimum number of skip points, that's what you need to find. So your answer for, if your array was, let's say, just from I up till n, okay, it was not the complete array, your array was only starting with I. So, or you can say if you start with the ith index. So this is the most basic way to basic state that we can think. Now if we take this state, let's suppose we are taking this state, can we write a transition for this state? Let's try. Okay, so always in the DP problem, let just try out some states and try if you can write a transition for that. And while if you are not unable to write a transition, then maybe change your states accordingly so that you are able to write a transition. This is like a general method you follow to solve a DP problem. So let's suppose this is the most basic state that we can take. Let's suppose if we take this state, can we write a transition for this state? So for the transition, what would we need? So if you want to write DPI, So dpi is if you start with the ith index, okay, then what is the minimum number of skip points. Now when you start, let's say you are starting with the ith index, you want to write what is my answer if I start with the ith index. So then I would say if I start with the ith index, then you move one step back. Let's suppose I was at I minus 1th index, and then let's say I kill one boss, then I can start fresh from the ith index. Or if I'm killing two boss, I would be at I minus 2 in the previous state. Okay, so whenever I am at some ith index, whenever I am at some ith index, then in the previous state, either I would be at I minus 1th index or I minus 2th index, because in one step, either you kill one boss or two boss. So these are the only two choices, that if currently I am at ith index, I am starting with ith index, then this state can be written by connecting it to either the I minus 1th state or I minus 2th state. Okay, let's say, but what exactly do we write? So if in the previous state I was starting with I minus 1th state, then in this state I am supposing that I am killing one boss and moving to ith state. Okay, so maybe I may write dp I minus 1. So I was at I'm so if I start with I minus 1 and then I kill one boss, okay, and then whatever the number of skip points to kill one boss, that would get added. So either it would be this, or it would be I start with I minus 2th state and then I kill two bosses. So dp I minus 2 plus number of skip points to kill two bosses. So it would be the minimum of these two things. Okay, but one problem. How do we write the number of skip points needed to kill one boss? So here if I am killing this boss, now I don't know whether I am killing this boss or my friend is killing this boss. So the number skip point was defined by if your friend is killing this boss, then and the boss is a hard boss, then add a plus 1. Otherwise add a plus 0. So now here while writing this transition, you don't know whether this boss is killed by me or my friend. Same way for this, you don't know whether these two bosses are killed by me or my friend. So you would have to like change your state slightly. What we can do to handle that? Like in this state, you there were like order of n states, but in with these states, I'm not able to write my transition like clearly. So I can add an extra state to it. What extra information is needed to me, that who is killing this boss? So I have only two ways for that. Either I am killing or my friend is killing. So I can take a 0 1 state. So what I can do is I can add an extra state I, let's say, and a boolean variable f. Okay, where if f equal to 0 means it is me, that I am starting from the ith index, and if f equal to 0, it means, let's say, friend my friend is starting from the ith index. That's what the definition. So it would be just n into 2 states, 2n states, that won't change my time complexity. It would still remain order of n. So now my definition of my dp changes. So my state changes is what can I write my new state as? Okay, let's say this was my previous state. I was not able to solve the problem. Now I take the new state, that dpi. Okay, I take two states, either dpi0 or dpi1. Okay, so I0 represents my answer if I start from ith index, and this is my answer if my friend starts from ith index. Okay, so whatever state like I was taking here, in that I just added an extra information. If another state is 0, that means I am starting, and if the state is 1, that means my friend is starting. That's what the change I made, and this is the new definition of my states. Now if I define my states like that, now can I write a transition for it? Let's see. So if the definition of my state is this, so I have an array. So if I want to write my transition for, let's say, dp I0, okay, so that means I am at the ith state, I am starting from the ith state. So before what would be the state previous to I? So either if it is my turn to start from the ith state, then for the I minus 1th and I minus 2th state, so either my friend would be at I minus 1th state and he kills one boss, then I reach here, or my friend is at I minus 2th state and he kills two boss and I reach here. These are the only two possibilities. So I can write that my DP I0 is either my friend was at I minus 1th state and he kills one boss. Okay. So this would be I minus 1th state. My friend was at I minus 1th state, so it would be I minus 1, 1. So if my friend starts from I minus 1th state and then he kills one boss. Okay, so if my friend is killing one boss, which boss is killing? This one. So if my friend is killing this boss, if it is a hard boss, then a +1. If it is an easy boss, then a +0. So its AI value is like that only. So I can just add A of I minus 1. So if it would be a hard boss, this would add a +1, otherwise a +0. Or the other case is my friend was at the I minus 2th state and my friend was at I minus 2th state and he kills two bosses. Okay. So if he kills two bosses plus I minus 2 plus A of I minus 1. So it would be the minimum of these two. Okay. So this is how you can write the DP state for DPI0. And same way for DPI1, what I can write is same like DPI1 is the definition for I am at like my friend starts with the ith state. So either I would be at I minus 1 or I would be at I minus 2 index. So it would be DP if I start with I minus 2 at index, and if I am killing one boss or two boss, it doesn't matter, it doesn't add any skip points. So either this or I was at I minus 2 state and it doesn't matter whether I killed one boss or two boss, no skip points added to it. So minimum of this. So this I can say is my transition. Okay, so this was my state, this was my transition. Now here you can see that my transition is I depends on I minus 1 and I minus 2. So to compute my I minus 1 and I minus 2, those previous states should be already computed. So I have to start my computation from the initial DP0 and then I have to move forward. Okay, so I would start from 0 and then move forward. Another way to write the states was, so this is one way to write the transition. Another way to write the transition would be, I may consider the next state. So this I can say is transition 1. This is one method. This way you can solve. Or the another method would be, if I am at the ith state, I can consider the next state that I reach. Okay, so I think this would be more intuitive and more easier to understand. That another way for the same state to write the transition would be, if I am at the ith state and then I have two choices, either kill one boss and move to I minus I plus 1 state, or kill two bosses and move to I plus 2 state. So if in this way I can write, then DPI0 is I am at the ith state, then this is my array A. I am at the ith state, then if I kill one boss, I would reach I plus 1 state. Okay, and my friend, it would be the turn of my friends. Okay, and if I am killing one boss or zero boss, it's not adding to the skip points. Another way is I may kill two bosses and move to I plus 2 state. So I may kill two of the bosses and it would be my friend's turn to start from I plus 2th state. So minimum of these two. And DPI1 is if I am at the ith index and my friend starts from the ith, sorry, my friend is at the ith index. Okay, and if my friend starts the turn from the ith index, then what would be my answer? Either my friend kills one boss, so I would reach DPI plus 1 and it would be my turn. Okay, and the cost of killing this ith boss would be AI amount of skip points. Or I kill two of my friend kills two of the bosses and I reach I plus 2th state. So he kills two bosses and it would be my turn to start from I plus 2 at state. And if he is killing two bosses, AI and AI plus 1, those skip points would be added. So it would be the minimum of these two. Okay, so this is another way to write the transition. I think this would be more intuitive and more easier to understand. So this is my second way of writing the transition. Okay, I hope the transition is clear. Either you can write the previous one or this one. Both are absolutely fine. Now, what would be my base case? I'm writing the base case only for this particular transition. Okay, for this particular transition, you would write base case based on DP0. Okay, initial. But for this particular transition, your DPI depends on I plus 1. So to calculate DPI, your ahead states should be calculated. So you would have to start your calculation from DPN and then move on to DP0. If you would have to calculate in this order so that all your states can be calculated. Because to calculate DPI, you need forward states. So you have to start your calculation from N to 0, not 0 to N. So if you have to start your calculation from N to 0, you would have to write the base case for DPN. Okay, and you like in the transition you can see that for DPI you are using two states, I plus 1 and I plus 2. So you would have, in the base case you would have to compute two states so that all the other states can be computed using those two states. So you would have to come in your base case, you would have to write DPN and N minus 1. Okay, so N0, DPN 1, DPN minus 1 0, DPN minus 1 1. You would have to compute all these values for your base case. Now, what would be these values? Okay, let's suppose I'm taking a zero based indexing. Okay, I'm taking a zero based indexing. So I have indexes from 0 to N minus 1. So what does my DPN mean? It means I have an empty array. Okay, DPN minus 1 means I have an array starting from the only A of N minus 1 is the only one element in my array. Okay, so if I'm starting from N minus 1, that means I'm starting from the last value. If I'm starting from N, that means I have already all the values are ended. I am starting from the value just after last. So for that, the number of skip points needed if I start from here is I have already killed all the bosses, so no skip points needed. Same way for whether you start or your friend starts. If I am at the nth index, that means I've already killed all the n bosses, so zero skip points needed. That's one base case. And if I'm at the n minus 1th index and it's my turn, so I would just kill one boss and use zero skip points. But if my friend is at the n minus 1th index, this is the final boss and it's my friend's turn, so he would have to kill at least one boss, so that would take a of n minus 1 skip points. So these would be my base cases. Okay, I hope the base cases are clear. So once you write the base case and then the transition, your code is done. What is your final answer? Your final answer is, how do you start? It's written that obviously DP0 would be like, to represent your final answer, you would use DP0 because you are starting from the 0th index. I'm taking a 0 based indexing. So initially you start from the 0th index and it's written that it's your first session. The first session is your friend's session. So you start with 0th index and it's your friend's session. That is the state. This state, whatever would be the value of this state, would be your final answer. Okay, so I hope the problem is now clear to you. Writing the code would be super easy now. Just write the base case and write this transition, and this is your final answer. Okay, so I think we can move on to the code now. So this is the code. In the main function, I take the t test cases and call the solve function for every test case. Now for every test case, I take the array input. Okay, once I've taken the array input, then I create a DP of n plus 1 cross 2. Okay, because I need to have states up till n. So I'll have to create a DP of size n plus 1 so that I have the nth index, and n2 is the second state. Okay, now I write these base cases. DP n0 is 0, n1 is 0, n minus 1 0 is 0, n minus 1 1 is this. So DP n0 is 0, DP n1 is 0, DP n minus 1 0 is 0, n minus 1 1 is a n minus 1. Okay, so I have written these base cases. After that, for writing the transition, how do I have to move? You know, for writing this transition, I depends on I plus 1. So I would have to compute from n to 0. Okay, so n and n minus 1 is already computed through base cases, so I would have to start from n minus 2 and move to 0. So I run a loop from n minus 2 to 0. Okay, this would be my outer loop, and then inside that I write these two transitions. So dp I0 would be minimum of dp I plus 1 1, I plus 2 1. Okay, this, and dp I1 would be minimum of I plus 1 0 plus ai, or I plus 2 0 plus ai plus ai plus 1. Okay, I write the transitions, and my final answer is dp01. Okay, dp01 is my final answer. Okay, super easy to write the code. I hope this problem is clear. If you just analyze the time complexity, this input part would take order of n time. Okay, I'm creating a n cross 2 vector. These are base cases. Here I'm running a loop n times, which is running. Inside that we have just two min functions, so which are order of 1. Overall, this is order of n. Okay, and this is order of 1. So overall, I can say my time complexity is order of n. And what would be my space complexity? I'm using a DP of size n cross 2, array of size n. So it would be order of 2n, which is same as order of n. So these are my time and space complexity. I hope this problem is clear to you. It was a really nice DP problem. Whenever you face such problems where there are something like you have two cases to move, or you have two choices, DP should immediately come to your mind. And whenever DP comes to your mind, the most basic way for an array to write DP is take a DPI, and which represents your answer for prefix and suffix, and then according to the situation you may take one more state, as we did here. So this was a very nice concept to learn about DP. Thank you so much for tuning in. Goodbye.